Okay, in this class we're going to continue the study of Modern Algebra 1, so let's take a minute and make sure we get our notes prepared. Your name and date at the top of the page. Modern Algebra 1 is the name of the course. The reason why it's called Modern Algebra is because there are older algebra books that we could study, but we're using a modern algebra book. So Modern Algebra 1. And in our last lesson, we completed through Article 38. So our next lesson, I think it's lesson 3. But what's more important is Articles 39 through 52. Articles 39 through 52. Now we're flying through these articles because it's just like definitions and terms and things like that. Once we get past Article 52, it's going to slow down. So we're just flying through these numbers of articles because the individual terms and definitions are labeled as articles, but that's not going to continue for long. In the previous 2 lessons, we've simply been learning definitions of terms. We've been learning about signs that are used and different ideas in algebra. Most of it has been pretty simple stuff. Some of it may have been new. In our last lesson, we talked about exponents and roots, squares and cubes, and things like that. We went through all those different signs, all the different symbols used in algebra. And in this lesson, the reason why we cut off at Article 38 for the last lesson is because Articles 39 to 52 really get into algebra. Okay, so I like to think that in Article 39, we're really getting into the study of algebra now. Okay, so a lot of the arithmetic stuff is behind us. Signs and terms that we use in arithmetic that we're already familiar with. We're past that now. In Article 39, we really start to get into new ideas that belong to algebra, and so you're going to have to pay more careful attention because this stuff is going to be new. All right? So we're going to have to work more carefully. I'm going to try to get through Articles 39 to 52 in one class. Hopefully we can do that, but I'm not sure. So it may turn out to be two classes. But this next section, which I think is lesson 3 in the Algebra 1 course, will cover Articles 39 to 52. So let's get started right from the text. Article 39. Every quantity or combination of quantities expressed by means of symbols is called an algebraic expression. So when we write something out using algebraic symbols, that's called an algebraic expression. It's used to express some quantity, some relationship in algebraic terms. It's an algebraic expression. And like I've said before, we have to learn how to read algebra. So if we take a statement like that, that's an algebraic expression. Okay, we have here an algebraic expression, 3a minus 4b. And if I were to ask you to translate this into words, what does this actually say in regular language? What does this say? 3a minus 4b. Who would try to translate this into a sentence? This is what we're going to start to learn. I just want to see if any of you can actually do it now. What does this mean? What does 3a mean?
Isn't like 3 to unknown quantity?
Well, you're close. 3 times a. All right, so this right here translates as 3 times some quantity called A What's next?
4 times.
No. Minus 4b. What does that mean?
4 and some quantity.
4 times some quantity b. That sentence is expressed in algebraic terms like that. It's a lot easier, isn't it? You can say 3 times some quantity a minus 4 times some quantity b, and we can talk like that all through algebra, or we can learn to speak with algebraic expressions and say 3a minus 4b, and say the exact same thing. It's a big improvement in language, isn't it? Okay? But this here is an example of an algebraic expression. Algebraic expression. Algebraic expression. I want you to get over these terms. I don't want you to be, intimidated by new words. Algebraic expression. It's just an expression made using algebraic signs and symbols. Okay? Nothing complicated. This is nowhere near as complicated as Latin or reasoning class. This stuff is easy. Algebraic expression. That's Article 39. So one of the things we're going to have to practice, and we're going to do this in exercises that are coming up, is you're going to have to take a bunch of algebraic expressions and translate them like that. And then you're going to have to take a bunch of sentences and translate them into algebraic expressions. So make sure you pay attention. Make sure you're taking notes. Article 40. The first important word we learn is, and again, this is all going to be new information, so you better pay attention and take notes. A monomial. Monomial. You can see these are going to be new words that you've never seen before. And just so you know, a monomial is the same thing as a term. Those two words mean the same thing. What is a monomial? Our textbook tells us a monomial, or term, is an algebraic expression that is not united to any other algebraic expression by a plus or minus sign. So a monomial is an algebraic expression not united to another. A monomial is an algebraic expression not united to any other by the sign plus or minus. A monomial is an algebraic expression not united to another by the sign plus or minus. A monomial is called a simple quantity. A simple quantity. And I want you to see something. Don't get lost in all these sciences. Don't get lost in all these studies. Think about all of your different subjects, because the textbooks that we use are good textbooks. And the sciences that we study are true sciences. What you're going to see is there's a lot of similar ideas from one subject to another. When we studied grammar, we learned that letters are the simple elements of speech, right? Letters are joined together to form syllables. Syllables are joined together to form words. Words are joined to form sentences. Okay? This idea of joining things together. In mathematics, it's the same thing. I should say in biology, we just learned in biology talking about chemical elements and compounds. We have simple elements, and elements are joined together to form compound elements, and compound elements are joined together to form complex bodies. We see in each of these sciences, there's something simple that's joined together to make something more complex, that's joined together to make something more complex. The same thing is true in math. The same ideas, same things are true. A monomial is a simple quantity, a simple quantity. And we're given some examples. Most simply, the quantity A. The quantity A by itself is a monomial. That's a monomial. It's a simple quantity. It's a quantity, it's an algebraic expression not united to another by the sign plus or minus. Okay? Is this an algebraic expression? Yes or no? Yes, it is. Is it joined to another algebraic expression by plus or minus? No. That's what a monomial is. That's what a term is. A simple quantity. A simple algebraic expression. Another one, I'm going to erase this so we don't get confused. Negative a squared times b. Negative a squared times b. Is this an algebraic expression? Yes, it is. Yes. It's an expression using algebraic signs and symbols. It is an algebraic expression. Is it united to another algebraic expression by the plus or minus sign? Is it united to any other expression? No, it's not. So even though this looks a little bit complicated, it's still a simple quantity. It's a monomial because it's not joined to any other expression by plus or minus. Is this a plus or minus sign? No. It's just a sign that says that this is negative. Okay? This is a simple quantity, a simple algebraic expression that is not joined to any others. So it's a monomial, even though it looks a little more complicated than just the quantity A. I erase this again. Let's look at another one. Two times A times B times y squared. Is this an algebraic expression? Yes, it's an expression of a quantity using algebraic symbols and signs. It's an algebraic expression. Is this an algebraic expression not united to another by the plus or minus sign? Is this united to another expression with a plus or minus sign? No. So is this a monomial? Yes. This is a monomial. It's an algebraic expression and it is not united to another by plus or minus. Then it's a monomial. Okay, keep that word in mind. In Article 41, we're going to learn another. I should put the article numbers up here just to keep this simple. 40 and 41. In Article 41, we learn a second name, polynomial. And just so you know, in all of your subjects, this poly means many. And mono, over here, mono means one. So monomial is one quantity. Polynomial, what do you think it means? If monomial means one quantity, many quantities, okay? It's simple. All right, polynomial. A polynomial is an algebraic expression consisting of one or more terms. A polynomial is an algebraic expression composed, not one or more, of two or more. An algebraic expression consisting of two or more terms. A polynomial is an algebraic expression composed of two or more terms. Now look up here. Up here we have this is an algebraic expression, right? This is an algebraic expression. The whole thing is an algebraic expression. It's like a sentence written in algebra language. So it is an algebraic expression. Is it made up of two or more terms? What is a term? First of all, what is a term? See if you've been paying attention. What is a term?
It's something that's not denoted by plus or minus.
Right, a term right here. A term is the same thing as a monomial. Okay? So over here where you see an algebraic expression consisting of two or more terms, it's talking about term right here. So we said this is one term, this whole thing. This is one term. It's not united to any other expressions by plus or minus. This is one term. A polynomial is an algebraic expression consisting of two or more terms. The letter C by itself, is that an algebraic expression? Yes. Is it right here, as it is it joined to any other quantity by a plus or minus? No. So this is a term. This is a monomial. You understand that? This is a monomial. So right here we have term 1. The quantity 2D. Is 2D an algebraic expression? Yes. Okay? 2D is an algebraic expression. Is 2D, right here, is 2D joined to any other algebraic expression by plus or minus? No. So this is a monomial. So here we have a second term. That's term number 2. This is a monomial. Monomial is just a term. This is a monomial, term 2. And then lastly, we have the quantity B. Is this an algebraic expression?
Yeah.
Yes. Is it joined to any other algebraic expression by plus or minus? No. So what is this? A monomial, which is the same thing as a term. So B is term number 3. So here we have an algebraic expression. We have an algebraic expression consisting of two or more terms. You see that? And why we say this is not a monomial, right? This expression is not a monomial. Why? Because there are quantities separated by plus and minus. So it's not a monomial, it's a polynomial. It's an algebraic expression made up of many terms. Polynomial. You got that? Okay? So we have one term plus a second term minus a third term. One monomial plus another monomial minus a third monomial. All of these together, joined by plus and minus, this is called a polynomial. It's an expression in algebra that's made up of two or more terms. Polynomial. Article 42 in our textbook, Article 42, introduces another new vocabulary term, binomial. Binomial. Take a guess. What do you think binomial means?
Against.
Nope. Binomial. Bicycle. Binocular. What does bi mean? Poly means many. Mono means one. What do you think bi means? Bicycle. Bicycle. Binocular. What do you think bi means? Man is a biped animal. What does bi mean? You don't know what bi means? But you have a guess?
2 feet.
Two. Good. Two. Bi means two. So a binomial, what do you think it's going to be? An algebraic expression made up of two terms. Okay? Let's see what the definition is. Article 42. A binomial is a polynomial consisting of two terms. A binomial is a polynomial. It's one kind of polynomial. A polynomial consisting of two terms. A polynomial, so it's an algebraic expression that's made up of two or more terms, right? So a binomial is a polynomial. It's two terms. Polynomial is two or more terms. So a binomial is a polynomial. It's one kind of a polynomial. Give me an example of a binomial. Make one up. What could you do? What could you do to make up a binomial? If you had to just think of a binomial, give me an example. You can use anything you want.
2 feet.
No, you're clueless guessing. We saw a monomial over here. We saw a couple of examples. We saw a polynomial right here. What would a binomial look like?
Would it be like that one down there plus the same thing?
Could be. It's term 1. Term 1 plus term 2. That would be a binomial. Okay? Give me an example of term 1. What could I put in there? Any example. A. Good. What could I put in term 2? B. That's a binomial. It's that simple. Okay? It could also be minus, right? Plus or minus. So that doesn't matter. It could be something minus something. It could be something plus something. But term 1 plus or minus term 2 is a binomial. Let's go back to plus here. Give me another example. Term 1. Give me another example. 2D. Plus 4x. Get the idea? It's just term plus a term. Term minus a term. That's a binomial. This is just term plus a term plus a term, or term plus a term minus a term, or term minus a term plus a term, or term minus a term minus a term. It's just two or more terms joined together by addition or subtraction. A binomial is just two terms joined together by addition or subtraction. It's not complicated. It's just vocabulary. It's just vocabulary. And kids struggle in algebra not because of numbers, not because of symbols, and that's not what causes kids to struggle in algebra. What causes kids to struggle in algebra is they never learn the definitions. They never learn what the terms mean. They never learn what the language means. And they just rush trying to get far ahead in math, thinking that they're going to impress someone. And they don't take the time to learn. So if anyone tells you that they've studied algebra, ask them to give you a definition of a binomial and see if they can. Ask them what is a polynomial and see if they actually learn the definition. And then when they tell you that they don't get good grades in algebra or they don't like algebra, they've never even learned the definitions because this is not complicated. Classical reasoning is 5,000 times more difficult than the study of algebra. The problem is that students don't learn the definitions and they try to move ahead to the next lesson and they're just lost because you have to learn the language of algebra. Okay? This stuff is not complicated. They like to use fancy words for some reason. You know, these words, I guess they make people feel smart. But all polynomial means is an expression made of many terms. All binomial means is an expression made of two terms. We can make this language much simpler. You see that? This is not complicated stuff. I think people like to pretend that they're really smart by bouncing fancy words around, but these are basic ideas. Okay, so a binomial. A binomial is a polynomial, so two or more terms, expression. A polynomial composed of two terms. A plus B is a binomial. A minus B is a binomial. C squared minus D is a binomial. And then we're given another vocabulary item in there under Article 42. We're told that if we have a binomial and the second term is negative, it's called a residual quantity. So if we have a binomial, this is what I mean. I feel like math books and math teachers love to pretend that their ideas are complicated, but they're not. Listen to this definition. Ready? A residual quantity sounds pretty impressive. Residual quantity. A residual quantity is a binomial in which the second term is negative. Sounds pretty impressive, doesn't it? A residual quantity is a binomial in which the second term is negative. You know what that means? That's what that means. This is a binomial. The second term is negative. This is a residual quantity. This is a residual quantity. That fancy word, it just means a binomial where the second term is negative. That's all that it means. Okay? Don't let the language intimidate you. Don't let the language become an obstacle. Because algebra, modern mathematics, these are not difficult studies. These are not difficult studies. So a binomial is a polynomial composed of two terms. Article 43. Article 43, moving on. Get ready. Complicated stuff. 43. What do you think a trinomial is? What do you think a trinomial is? Huh?
3 terms.
An algebraic expression composed of 3 terms. Trinomial. An algebraic expression consisting of 3 terms. Okay, so whatever this may be is term 1, plus or minus term 2 plus or minus term 3. That's a trinomial, plus or minus. Okay? Term 1 plus term 2 plus term 3. Term 1 minus term 2 plus term 3. That's a trinomial. So give me an example what term 1 might be.
2D.
Go ahead, be a little fancy. 2d squared. Okay? Term 1, term 2.
4x cubed.
4x cubed. Term 3. The cubed root of a to the third b squared. That's just one term. Algebraic expression, not joined by plus or minus, right? But it's just an expression consisting of 3 terms. That's all it is. That's all it is. That's all it is. An algebraic expression consisting of 3 terms, a trinomial. These things aren't difficult. If you understand what a monomial is, if you understand what a term is, all of these other definitions are really simple.
There's an example for a trinomial,
What?
like a tricycle.
Well, that's that's what the prefix tri. The prefix tri just means 3. It's just an algebraic expression made up of 3 terms. Binomial, algebraic expression made up of 2 terms. Trinomials and binomials are kinds of polynomials. Because a polynomial is 2 or more. Binomial is a polynomial. A trinomial is a polynomial. But these concepts are not complicated, okay? Back to our text, Article 44. Hold on, there's someone named. Okay, Article 44. The numerical value of an algebraic expression, let me get the board cleared here for a minute. Article 44, numerical value okay, so if we have a trinomial like a plus b plus c, or a minus b plus d, if we have a trinomial or a binomial a plus b, we see this as an algebraic expression, but we can have a numerical value for this expression. We can have a numerical value if we assign a numerical value to each of the terms, or to each of the symbols in the expression. So for example, if I said a equals 5, b equals 2, and c equals 1. Okay, if I gave you values for these different quantities, we can find the numerical value of this expression by substituting numerical values in for the letters or for the terms that the expression is made up of. So if we had a plus b plus c, and a was equal to 5, and b was equal to 2, and c was equal to 1, the numerical value of this expression would be 5 plus 2 plus 1, which is what?
8.
All right? That would be the numerical value of this expression if a equals 5, B equals 2, and C equals 1. Pretty simple, right? You just plug the numbers in and find the value. So here we have A minus B plus D. If, let me add a D here. D equals 4. So on your paper, find the numerical value of the expression A minus B plus D if A equals 5, B equals 2, C equals 1, and D equals 4. Find the value of this expression. Just hold on. We'll go through it together. We're told that A equals 5. We're told that B equals 2. And we're told that D equals 4. So 5 minus 2 is 3, and 4 make 7. So this is the numerical value. This is the numerical value of this algebraic expression if A equals 5, B equals 2, C equals 1, and D equals 4. Okay? What we're doing here is finding the numerical value of an expression when we're given values for these missing quantities, okay? You understand that? We simply plug the numbers in and find the value of the expression. Okay? Because remember in our first lesson I talked about how in algebra the reason why it's helpful to think in algebraic expressions is because quantities can change in formulas and things like that. Quantities can change. So if I know that these are the quantities, let's say right now, I can use this expression to find the value. But these values can change 5 minutes later in some real life situation. These values can change and I can recalculate the value. And I can recalculate the value and recalculate the value as often as the quantities change. That's what it means to find the value, find the numerical value of this expression. That's Article 44. The number obtained by giving particular values to the letters and then performing the operations. Let's try another one. We'll keep these quantities. What would 3a equal? What would 3a equal? 15, okay? It's just 3 times 5. What would a squared equal? Do you remember what a squared is? No. No? 25. A squared is equal to a times a. If a equals 5, a times a is 25. A squared. Okay? What would, let's see, AD over B equal? AD over B. Which is 10. Well, just 10. 10 over 1 is just 10, right? A times D over B is A times D. 5 times 4 is 20, divided by B, which is 2. 20 divided by 2 makes 10. So the numerical value of AD over B, and you hear how I read it? AD over B. The algebraic expression is very simple. AD over B if A is 5, B is 2, and D is 4. This is what it means to find the numerical value. Find the numerical value of this expression. Okay? That's Article 44. Now, Article 45 is just a note about solving, finding these numerical values. The numerical value of a polynomial is not affected. The value of a polynomial is not affected, is not changed if we change the order of the terms. The value of a polynomial is not affected by changing the order of the terms. If each term retains its sign. So if I have a squared plus b minus c. Okay, I have this. This is my expression here. It's a polynomial. It's a trinomial, right? If I change the order of the terms, if I change this to be b minus c plus a squared, is that the same as this? A squared plus b minus c, is that the same as b minus c plus a squared? Are these the same quantity? Same value? Yes, they are. The rule tells us, Article 45, the value of a polynomial, listen, you have to pay attention. If you're lazy-brained and you're not going to pay attention, you're going to be lost with no excuse. This is why so many students in modern schools are just lost. The teachers may explain the stuff and they don't pay attention. Article 45 says the value of a polynomial is not affected by changing the order of the terms, provided that the signs are retained. As long as you keep the signs the same, the value does not change if terms are moved around. So we kept the positive b right here is still positive b. The negative c is still negative c. And a squared, we learned that anytime we see a quantity with no sign, it's positive. And so we moved and changed the order, but we retained the sign. So this quantity, this expression, has the same value as this expression. It doesn't matter if you move things around, as long as you keep all the signs the same for each term. Okay? The value of a polynomial is not affected by changing the order of the terms, provided that each term retains its respective sign. Okay? So what I'd like you to do here, we have a minus b. I'd like you to restate this expression, changing the order of the terms, but not changing the value of the expression. I want you to rewrite this. I want you to change the order of the terms, but not change the value. How can you do that? How can you do that? Change the order of the terms, but do not change the value of the expression. What do you think? How can I rewrite this, changing the order of the terms?
B take away A.
Okay, Sam says B, take away A. Did Sam change the order of the terms? Yes. Did he change the value of the expression? Yes. Why? What did he get wrong?
It used to be 5, take away 2.
No, you can't do that, and I'll explain why. Don't put numbers in, because that can lead you to wrong answers. Think of the rule. Don't think of specific examples. Think of the rule. A minus B, is A minus B the same thing as B minus A? Just think in general terms. Is A minus B the same thing as B minus A? Listen to the rule again. Ready? Listen. The value of a polynomial, this is a polynomial, the value of a polynomial is not affected by changing the order of the terms, provided that each term retains its sign. What's the sign of B here? Negative. What's the sign of B here? Did it retain its sign? No. That's what's wrong. So you have one thing to fix. A here, what is its sign? So what happened? We changed the order, but we didn't retain the signs. Right? What should the sign of B be? What should the sign of A be? Now they're the same. Okay? Now they're the same. Somebody rewrite this expression over here in different order. Change the order of the terms, but don't change the value of the expression. Who can do it? Want to try it? Go ahead. Tell me what to write. I'll write it.
Positive C.
Okay. Positive C.
Take away minus B.
Take away B.
Plus A.
Plus A. Did he change the order of the terms? Did he retain all the signs? Did he retain all the signs? Here we have positive C. Over here, what do we have? Positive C. Here we have negative B. Over here we have positive A. Here we have positive A. Did he change the order of the terms? Yes, he changed the order of the terms. Did he change the signs of the terms? No, they're the same. So this value is the same as this. We can change the order of terms as long as we change as long as we keep the signs the same. You understand that? Everybody says yes, but if I ask the question, you all get it wrong. You can change the order of terms as long as you keep all the signs the same. Okay? A plus B is the same as
A plus B plus.
No, I don't know where you would get that from. A plus B is the same as
Positive B and positive
B plus A. Positive A, positive A, positive B, positive B. A minus B minus C equals, change the order.
minus B minus C and positive A.
That's all it is. The value does not change as long as you keep the signs the same. And by the signs, I mean positive and negative. As long as everything positive here is positive here, and everything negative here is negative here, the value does not change. So, if we were to fill in the numbers now, if we were to fill in the values, these would both be the same, these would be the same, these would be the same, these would be the same, because even though we changed the order around, we didn't change the signs. If you change the signs, the values will not be the same. Okay, that's Article 45. You're going to do some exercises with that, so I'm not going to worry about that too much. That brings us through Article 45, and it's 3:30. I think we started at like 2:40, right? So we're gonna stop there. Article 45, we're going to stop at. So we got from Article 39 to 45, about halfway through. I want you to study this part of your book, Articles 39 through 45. If you do the work to understand these topics, you're going to find that all of algebra is very easy. If you get a hold of these topics and study them carefully and make sure you understand them, all of algebra will go easily. If you don't pay attention and lazily try to slide past this lesson, you're going to be confused the whole course. And that's your warning. All right? So we went through Articles 39 to 45 in this class, and we're going to wrap it up there. So take a minute, write a summary in your notes of what we studied in this class, and that will be all for our first part of Lesson 3 in Algebra.